Hello. Hello, hello. I think it's live. Mayhaps. I think it is. Yes. Today I start late again. I don't know how I managed to do this. And we're gonna do some math. Yay. Algebra. I'm so late. I'm so far. Okay. Let's not stress. Let's not stress ourselves. Barely starting. Something on my tablet. There we go. So I did a bunch of thingy while removing it. There we go. Don't know what this is. Anyway. So yeah. My head hurt, but surely it's gonna be fine. And yes, mass, 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 mass. I'm gonna be the very best, like no one ever was. Blah blah blah. Blah blah blah. Prove that the ring. Maybe I don't know which one I should do first. I mean, I don't have the correction for this one, so it's kinda bonkessy to do it. Arco prime. We denote by Z the set of inversible element of the ring Z and Z. Ah. Is the group the class A is inversible? Blah, blah, blah. So yeah, if A is inversible, then A bar belongs to the Z and Z inversible, and then if it is inversible, then it verifies the I forgot the name, but the AV plus BU equal 1, i.e. Like AV is congruent to 1 mod E, i.e. A and B co-prime. Blah, blah, blah. Replace B with N and this works. So yeah, I think it's that. Prove that the ring is the field. Z and Z field and prime ring Z and Z ring with no zero divisor. So it is stable by division. What is a field again? Because my definition of a field was a ring in my head. Wait, so they are different? Field and ring. No. Prove that the ring Z and Z is a field. If and only so ring and field are different. What's the property of a ring again? They're so big. I need to redo this thingy. Morphism, property. Look at all the space. There's barely anything written in all of this. All the space I took. Wait, so I guess just look above. Blah 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 blah. Quotient. This is equipped with a ring structure. So yeah, a ring is a group associated with an internal law that is additive and an external law that is multiplicative. So what more does the field add? Ah yes, the field is French. I don't remember the French. It is. It means. It means all of its elements are different from zero are inversible, right? Yeah. 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 Mm-hmm. 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 we are here. A field, a field, a field. So if it is a field thingy, A in C and Z, there exists A minus 1, such that A minus 1 equal E, equal 0. A bar, I, E, A bar, as in A plus NZ plus A minus 1 plus NZ equals 0. Should I use the multiplicative definition or the additive thingy? No, if it is invertible. Yeah. If it is invertible, it's not 0, it's 1. Pepega. You dumb. You dumb. 1. Therefore, we got blah, 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 blah. We got A minus 1 equal 1 mod n. I.e. A congruent to A mod n minus 1 mod n. A. Right, I went from the definition of something invertible. This is it, right? This is a thingy plus mod n and mod n z equals 0, i.e. it is congruent to this. Congruent, i.e. A, we just multiply by a minus 1 on the right. Wait, no. If I do a minus 1 on the right, then I end up with so I end up with a equal a mod 1. Yes, thank you, yes. That is indeed how it works. Hmm. I lost my focus. Fuck. A minus 1 equal 1, i.e. A is congruent to mod 8 mod n mod. Allo, 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 allo. Allo, 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 allo. Kola no sponsor no tekyo de okorishimasu. Hmm. My bad habit of just staying stuck when I'm stuck. Just staring in the void when I'm stuck instead of trying things. Yeah, A is congruent to A minus 1 mod N. Hmm. Wait. Hmm. No, not how it works. Ah, yes, 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 yes. Equal 1 mod N, i.e. A E plus A minus 1 UV U V equal 1, i.e. N, i.e. i.e. Equal 1, i.e. A is congruent to 1 mod N? Wait, that? No. Huh? I mean, if it's this, then it's done. It means A and N are coprime. I mean, coprime doesn't mean N is prime. Ah. Ah. Ah, yes, it means it is prime because all elements that are inversible must be coprime with it. Therefore, all elements different from N are prime with it, therefore N is prime. But is this the is it Bezu? Bezu. Oh god, I remember the name. Bezu, 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 Bezu. Et means that 1 is congruent to 1 mod N. I think I jumped a step. Da, 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 da. GPT. GPT. Hi. Stuck trying to that the ring Z and Z the field EFF edge prime. Let's denote the ring of integer modulo n as n z and z. If n is a prime, then n is a field. Let n be a prime number, then for any non-zero, the greatest common divisor of 1 and n is 1. By Bezo's identity, there exists an interior x and y, such that ax plus ny equal 1. Reducing modulo n, we get ax congruent to 1 mod n. Okay, I jumped a step. So au congruent to 1 mod n. And here I use a. Here I use. Ah no. If I write this, then I wrote modulo a minus 1. So it's wrong. Wait, so with the little hint that I read at the beginning of the explanation, is a field. It means all A in Z and Z are invertible, i.e. A congruent. No. What did I miss again? Let n be a prime number, then for any non-zero A in Z and Z, the greatest common divisor of A and n is 1, since n is prime and A inferior to 1. Ah, wait. I'm just reading the... So if Z and Z is a field, then n is a prime. Okay, let's... Ah, yes, wait, I read in the wrong... the wrong order. I want first to show that from a field we get that n is a prime. So assume Z and Z is a field. For every non-zero element has a multiplicative inverse. Suppose n is not prime. I just had to do this? I did it in the wrong order. Suppose n is not prime, so n equal AB. Okay. With this hint, let's do the rest. If n, suppose n equal AB. AB. And from there, what do I do? Then I have to shoot is a field. So for all A in Z and Z, we should have that A x plus n y is equal to 1, i.e. ax plus aby, i.e. a congruent to 1 mod ab ax. No, I don't know. I'm stupid. If Z and Z in Z and Z, neither A nor B has an inverse, because any multiple of A or B will never be 1 modulo n, since n equal AB. This contradicts the assumption that n is a field, therefore n must be prime. Neither A nor B has an inverse, because any multiple of A or B will never be 1 modulo n. What am I missing? Ah, then. We have to find that A, Z, and Z. We have A, Invertible. Inversible. I don't know how it say. It's invertible. Inverse. No. Ah, my head hurt. Neither A nor B has an inverse. A. I don't get it. I'm missing something. I'm missing some core understanding of the group. Bezu. AX plus BY equal 1 means AX is equal 1 mod E, right? Theory 4, theory 4, theory 4. X plus N. Ah, because I guess if we got an AX plus NY equal 1 means that AX plus ABY equal 1 means that AX plus B, A plus A X plus Y equal 1, i.e. A equal X plus B minus 1 or X plus BY equal A minus 1. Where is the issue? Assume Z and Z is a field. By definition, it means that every non-zero element has a multiplicative inverse. Suppose, for the sake of contradiction, that n is not prime, blah, 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 equal to A times B, to AB. Consider the element A and B in Z and Z. Since n is equal to AB, we have A, wait, that's some formatting error, A C dot B equivalent 0 P mod n. Means the product of A and B is 0 in Z and Z. Ah. So we get AX plus ABY equal 1, or if X equal B, then we got 0 plus ABY equal 1. And if Y is equal to, but AB is equal to 0, 2, no. No. Huh? N is the order of something, does not mean N is equal to 0. 8 times B is the order. This means that A and B are non-zero element whose product is zero, which contradicts. Since n is equal to AB, we have A. There's a little. Okay, it cannot for the life of itself tell me what AC dot B equals 0 mod thingy means. It's the step I'm stuck to, so it's kind of AC dot. Wait, let me just Google what this means. What does this mean? Mat stack exchange. Aha. So it's A dot, so it's a times a mod n. It's called blah, 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 blah. So A times B is equivalent to 0 modulo n. Ah, because it is equal to like n, i.e. it becomes the 0. Yes, dummy. It works because we are in the quotient group. Okay, I get it. Wait, no, yes, here. Wait, this means A x plus A, but it's not modulo n yet. G equal 1. Y. Ax. Is congruent to 1 mod AB if x equal to b. Then we got AB congruent to 1 mod AB, 0 congruent 1 mod AB. Right, so it does not work. I think it's that. On this note, let's take my break. It's that's what I thought. My head kind of hurt. Oh. My head hurt. Oh my god. I'm singing. I need to get back to studying. I need to study. Yare, yamero. Big music is not gonna cut it. Me, I need to. I need to. Okay, okay, I'm getting okay. I'm studying for real, for real. Okay, okay. Okay. Wallahi, I'm finished. Wallahi, wallahi, I'm finished. Oh my god. Okay, 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 let's go. Did we finish this exercise? No. Am I gonna do something else? Yes. Theorem demonstration not corrected, therefore I'm not gonna do it. If P is a prime number, the Fermat little theorem. As if it's gonna fall on the exam. Hop, hop, theorem. Blah, blah, the Chinese remainder, the number of invertible elements. Blah, blah, blah. Exercise. Prove that something is a group isomorphism. The group isomorphism. As it Z and Z inversible, isomorphic to the automorphism Z and Z. Mm-hmm. We have to show that the automorphisms mean isomorphism bijective. Ah. Okay. Hmm. I did not change my stat or my objective. I have no idea. I don't know, bro. Let's say we did one exercise. If P is a node prime and M an integer greater than 1, equal to 1, then ZPMZ invertible is a cyclic group of order phi PM, yeah, i.e. it is isomorphic to that. Okay. Yeah, just a phi de P, phi power M. The group Z2Z star and Z4Z star are cyclic group. of order 1 and 2. For any n greater or equal than 1, the group Z2MZ star is not cyclic. It's not isomorphic to the -1. Fumu. Automorphism is a bijective morphism. Bijective morphism. Prove that psi is a group isomorphism. So K belongs to the invertible, so it is prime with n. I don't know why I'm in red, but okay. Into the automorphism. That's out. There's one too many. My U is badly written, but that's out. K. Z and Z. Into Z and Z. Forgetting this. Alpha. K alpha. So K n are co-prime because it belongs to the invertible. So K A. We have to show it's a bijection. It's bijective. Or I have to show that the indications shows that the automorphism means morphism bijective. So I have to show it is a bijection. So I have to show the surjectivity, the injectivity. Surjection is there exists right, so yeah, we suppose K and alpha is equal to K alpha prime. That's the alpha that is movable. So K alpha prime alpha equal alpha prime. Did I? Oh yeah. I'm supposed to write like psi of K alpha because it's like a two-step. Oh my brain. Should avoid singing. It rings in my head and it's kind of bad when I have a headache. I mean, K is fixed. I don't know if it's a K or a kappa, I don't care. So then we end up with this. My head. Exercise number of solution of x square minus 1 equal 1 in the ring. Oh my god, and determine them explicitly. The order dividend. Ah yes, I need to do a Bezoar identity. So I need to search for the elements that are their own invertible. Ordre divisant 2. Ah yes, order 2. Okay, so I have to do 391 divided by 2. Wait, 2 times 100, 200. 2 times 150, 300. 91. What is the closest to 91? 2 times 40 is 80. 2 times 42 is 88. Right? No, it's 44. Math. 2 times 45. Yes, math. 2 times 45. So 2 and 150 plus 45, so 195. Remainder 1. Remainder 1. So 1 equal 391 times 1 minus 2 times 195. Let me check this thing is real. Let me check the one piece is real first. 195 times 2. Yeah, 390. Yeah. I can math. Uh-huh. And I forgot what we do with the idea of Bezoar. I mean, I have it in my last year exercises. But if it was last year, he's not gonna ask us to do it again. For it's gonna be fine. It's gonna be fine. Let's do something else, bro. I don't know. H is a subgroup of a group G, the number of equivalence class. That's the definition. Blah blah is called the index. Blah blah blah. Remark. J is finite. Hx minus 1 is the bijection with the set of left coset and the set of right coset. Conjugate, blah. Example. E. 2 means 1 is complementary of the other. Center of a group is conjugated with the group. Example, any. My head hurts. Any permutation can be written as the product of cycles with joint support. Decomposition is unique. The type, blah, if they are at the same time, they are conjugated. Prop. The group is normal. The law compatible. For the law. Exercise. Without corrections, of course. H to a transposition. V sending me some Instagram reels, of course. Kawaii. Yops. Who am I? I am me. Not really useful to know, but good to know. Yes, so transposition, blah, 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 verifies that the law of the nun does not pass at the quotient. Indeed, let transposition. We have thingy equals thingy, and thingy equals thingy, i.e. thingy equals thingy, and thingy equals thingy, but we have thingy. That was the correction, maybe? Bacana. Never mind. Since it was the same color, I thought it wasn't corrected. My apologies. Apologies. Wait, I'm curious. Has my studying stream been shown at all to people? Content, impressions. Maybe I should go to content, like, I don't know, a study stream I did a while ago. Were there any impressions? 17 impressions. So it is shown a little. I mean, no one clicks because I understand. I get it. Couverture, 5 impressions. Ouch. one that is way longer ago. Previews, that's V, must be V. Couvertures, 215 impressions, damn. 4 unique spectators, nani? People clicked? Different people that are not V clicked? I don't know, I'm capping. Is it really not V? Oh, I kinda, it says unique, so I guess not the same account, right? I don't know. I'm impressed. I was expecting like not a single view. Because it's like that for my second channel where I put my edited stuff. Nothing get any impressions. That's how it is for a new channel. Since I do not advertise because I don't know how and I'm too shy to look how. I'm not too shy to look how I could, but I know that even if I look how to like advertise your stuff, I won't have the balls to do it. So I don't know. I'm not confident in my content. Well, I did work hard for my atelier edit. I cut like over 30 minutes. I just left the story and added some editing. So yeah, anyway. H equal thingy. Thingy is equal to the transposition 1, 2. In this, verify that the law on n does not pass at the quotient. The law does not pass. I don't really understand the text. Indeed. T equal to 3, T2, T1. T1, T2, T2, T1. T2, 2, 2. I cannot write for the R. 2, 1, 3. 3, 1, 2. 1, 1, 2, 3. Viva l'Algérie. Sigma 2, 1, 3, 2. 1, 3, 2. Viva, I don't know. So T1H is equal to T2H. Why? I mean, T3 and H are equal, right? So we have, wait, it is equal to the 2, 1, right? T1 2 is equal to sigma 2 H. What is sigma 2? Is 1, 3, 2. 1, 3, 2. And if we fuse it with 1, 2, then we get 2, 3, 1. Am I not supposed to get the hmm? No, T1 is 2, 3. Sorry. I misread. So we go T1H, that is equal to 2, 3, 1, 2. 1, 2, 3. So we do 1, 2 first. We end up with 2, 1, 3. And then we got 2, 3, we got 3, 1, 2. And sigma 2H is equal to 1, 3, 2 associated to 1, 2. So we end up with 1, 2, 3. We end up with 3, 1, 2. And we associate with white wrong order. One, 3. So 1 2 are exchange. 2 1 3. Then we do this one. 2 become 3. Oh, well, 1 become 3. 2 become 1. 1 become 3 becomes 2. Am I mentally retarded or? Ah wait, no, wrong order. I was right the first time. I'm stupid. My apologies. My apologies. This one was in the wrong order. Oh, anyway, I get it. I'm sure they are the same. Whereas the other stuff are the same, but i.e. T1 equal T2 plus the sigma 2 and T2 equals sigma 1. However, T1 associated to T2 is different from sigma 2 sigma 1. So it's not transitive? Ah, Marek, oh my god, did not notice. Already? Huh? I did nothing incredible. I'm cooked. It's over. It's over, it's over. Saitami, Kanashimi, Wakaranai yo. I have to go back to the grind. Uh, hmm. Mhm. Is Singy, blah, 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 blah. Well, maybe let's maybe not use a specific example, or I'll dock myself. Why did I say 257? It's 123. I can't read. Why I write so bad? Anyway, let's jump this one. Mhm. C'est normal subgroupe 1, call de n alternate group. Subgroup of index 2 and the kernel of signature morphism. Maybe I should study more my definitions instead of this. No, exercises are important. Normal subgroup of the initial. I'm so stressed realizing how little time I have and how much time I'm wasting. Even surjective homomorphism. Even isomorphism. Blah, 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 im. Okay, anyway, next. Definition left action. Yes, an action is okay. The ex is equal x and ghx is equal to ghx. Yeah. Hmm. Mm-hmm. XEX, X, one can view an action as morphism from G to the symmetric group. Mm-hmm. Blah, then the map is a permutation of G. It's a group homomorphism. A proof. Oh my god. Yeah. Yeah. Mm. And for every G, the map. For every G. X, X, E, permutation of X. Mm. And P from G into thingy G, G, G. The group homomorphism. Mm. What did it say? Is G axon G, G X X, and for every the map permutation. G, P, G. So it is the map from G to the permutation G, right? G to GX. Uh-huh. Conversely, if G onto PG, homomorphism from G to nana, then the map is an action. There is a two-way correspondence between the set of action of G on X and the set of homomorphism from G to sigma X. Hmm. Hmm, I don't know. Let's look at the proof and try to understand, and let's try to redo it later. I don't even know what I'm supposed to show. Hmm. Ah, an action, okay. I have to show it's an action. So P of X equal to EX equal X. Then P JH, no, PG wrong. PH is equal to PG of HX is equal to JH of X. GH PG of X. So I showed this was an action. Thus, blah 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 blah. In particular, yeah. Ah yes. Ah, G G minus 1 is equal to phi E equal ID of X. So thingy is bijective. It is. An action is bijective by default? I forgot the definition. Mm. Mhm. And the map, I'm missing a word, but the map. Conversely, if the next morphin, then the map is an action. Hmm. Conversi Ledgy, group homomorphism. Homomorphism. Group homomorphism from J to Thingy. Ah, so it is a permutation. T X, okay. We define. So you have to define the PX. It's just a okay, it's just permutation. Okay. Goes to what, to X EX equal the permutation of G on X. We have to show it as an action. We have for any X, EX, PE, no. X in X, get PGX is equal to GX. Wait, no. I'm dumb. EX. So we take G is equal to E. And you have to show it as an action. So then I have PGH, I guess? Yeah. Yeah. If GH in G, X in X. GH X or not is equal to PG from PHX. Mm-hmm. Mm-hmm. Just define an action. It's an action of the group G on G on X. Uh. Mm-hmm. I forgot to stretch in the last hour. Aïe. Aïe. And painful. XY, connect, CFF, an equivalent relation. Ah, so an action is equivalent. Relation is called orbit of X. The orbit. Ah, the class. Ah. The relation. IFFF. There exists G such that Y, GX. My brain. The class of X and this relation is called the orbit. Which relation? Y equal GX? Equivalent relation. The relation is called the orbit of X, denoted by orb X or GX. And the set of orbits form a partition of X. Ah, so it is an equivalent relation. Yeah, yeah. Focus me, focus, focus. It's the break already, and I don't count this as break. I was just focusing on the wrong thing. The direction is transitive or that x is transitive unless if there is only one orbit. Oh, okay, okay. I'm supposed to be doing exercises, not studying for my class. What me say to you? The set of orbit forms the partition of it. Because it is an equivalent relation. Yeah, so it is a class called an orbit and it forms a partition because it is an equivalent relationship. The kernel of the action is the kernel of the associated homomorphism. G, phi G. What am I not understanding from the G to Cx? Yeah, we said G, and then we said the permutation G on X, of like just the action of G on X. So I guess my mind struggled because we set two stuff. Sorry So the action is transitive, or that acts transitively. There is only one orbit. It is faithful if the associated. Okay, if it is injective, yeah. I.e., if the kernel is reduced to E. Oh, he. Ah, break. Ah, la, 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 la. It's done. Nah. Yada yada. Mhm, 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 mhm. Ba-da-ba-ba-ba-ba-ba. Ba-da-ba-ba-ba-da-ba-ba. Mm. La la. Asai showadare odododotsumana. BRB, let's stretch a little and let's get back to it. Ah, la, 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 la. I forgot water, BRB, 2 seconds. Wait, so how many Pomodoro did I do? 2? 3? I forgot. 3, yay. No. Okay, let's go. Let's go. Blah 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 blah. Example. The group of rotation of R2 about the origin, axon de set R2, the orbit are circles around are circles centered at the origin. Blah blah blah. Oh là 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 là. Ah yes, transitive if it is if there's only one orbit and it is injective. It is faithful if the thing the interaction is injective. Yeah. If X is set, what is this example? Is it an exercise? The group of rotation of R, rotations on R, but the origin O acts on the set R2. The orbits are circles centered around the origin. The action is not transitive because there are a lot of orbits, yeah. It is faithful because the only rotation that fixes every point in R is the identity. Yeah, if you the identity is in a 360. Yeah, it's a 360. As in E. I don't know. It is faithful because the only rotation that fixes every point in R is the identity. And I guess the identity in the rotation is yeah, a 360, so just going back to your original placement. If X is a set, the group thingy X of permutation of X acts on X by permutation. I have food stuck in my throat and I finished eating hours ago. Hell stomach, for real. Need to study harder, more harder, more harder and more harder and more. Il est ouf. 真っ黒に塗りたくられた世界。何を描いても見えしないよ。大丈夫だって注いで。一人きりの触れてるの。Okay, food fixed. Throat fixed. Focus. Focus, focus, focus. Focus, focus. Bam, 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 bam. If X is a set, the group sigma X of permutation of X acts on X by permutations. So what's phi X? What am I writing? Not a G. X. Oh my god, I cannot write X on X, so permutation of X on X. So sigma is the permutation. Sigma on X on X, then just a sigma X. Indeed, let X in X, we have EX equal to it is an action because it verifies that the ID is inside, and that if you associate two permutations, then we can just fuse them. The action is transitive. Indeed. The first example was not transitive, so the group rotation was not transitive but faithful, and this one is transitive, and I guess it's not faithful. I don't know. Is it transitive? Never mind, I still have some pieces of salad going back from my throat. I didn't chew my salad enough. Bad me, bad me. Bad yen, bad yen. Faithful is what again? There's only one orbit. What is an orbit again? I forgot. Indeed, for any x I click in X, there exists a permutation sigma such that I is equal to phi of X. Ah. Example, transposition which switches X and I. Isn't it transitive if there exists only one? Right, let me go back up. If there is only one orbit, no? For all x I in X, there exists a G such that I is equal to G on X. There exists a permutation sigma such that I is equal to sigma G, sigma X. Is it some form of surjectivity of the action? No. For any x I in X, there exists a permutation. So I guess as in one permutation such that I is equal phi of X. Y equal phi of X. So there exists only one, I guess. Is it faithful? So is the kernel only the identity element? I do not know to show this. As in, we need to show the kernel is equal to. So as in, we need phi x equal x. So yeah, it means if phi x, yeah, the identity, as in the identity of x. The only thing that verifies this is the identity. So yeah, it is indeed faithful. I'm already tired. Oh my god. More ciblé, c'est. Je pète ma bière. Manipulé. I love this image, this video. Focus, 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 focus. Every group G acts on itself by left multiplication. G, 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 X, I guess it was an X, but I wrote G by mistake. So it is G, X. It is an action. Well, I mean, if your E is equal to 1, then yes. Hajime mashite. Lock in, lock in. So yeah, it is an action, E is equal to X. G and X is just multiplication. The same if you multiply first. I mean, multiplication is associative, so it works. Is it transitive? Transitive as if there's only one number such that X multiplied by one number is equal to one number. I mean, there's only for all X, Y in G, there exists G. It keeps saying it exists. Even though I wrote there exists only one. Wait, let me ask GPT. Hey, you. When we say an action, is the orbit unique. When we say an action is transitive, is the orbit unique? Hello, when you say that an action is transitive, it means that for any two elements X and Y in the set being acted upon, there exists a group element G, such that G is equal to Y. In other words, the group action has only one orbit. So there exists G, so it shouldn't it be there exists only one? To answer your question directly, yes, the orbit is unique in the sense that there is only one orbit that covers the entire set. However, it's important to note that the orbit is not unique as a subset. It's the whole set itself. So while it's accurate to say the orbit is unique, it's more precise to say a transitive action has only one orbit. Namely Y X minus 1. Shouldn't? What? I mean, this is the nuance that my small brain is scoping to understand. There exists a group elements G. In other words, the group has only one. Isn't? But I don't understand. G isn't unique there. I see where the confusion might be from. Let me clarify the concept of transitivity. Thank you. And orbits. And address the uniqueness of the group element G. Transitive group action. A group action of a group G on a set X is called transitive if for any two elements. There exists a group element G such as an orbit. The orbit of an element under the action is the set of all elements in X that can be reached from X by the action of sub-element of G. Formally, the orbit of X is Gx. I can feel my brain sleeping, not able to grab on the concept. The orbit of an element X is the action of G. Under the action of G is the set of all elements in X that can be reached from X by the action of some element of G. Formally, the orbit of X is orbit of X equal G times X with G in G. Uniqueness of orbit. In a transitive group action, there is only one orbit, and that orbit is the entire set X. This means that for any X, the orbit of X is X itself. The group element G that maps X to Y is not necessarily unique. There can be multiple group elements that map X to Y. To illustrate this, consider the following example. X1, 2, 3 and G S3, the symmetric group of the three elements. The action of G on X is defined by permuting the element of X. Consider X equal 1 and Y equal 2. One possible G that maps 1 to 2 is the permutation 1, 2, which swaps 1 and 2. Another possible G that maps 1 to 2 is the permutation 1 to 3, which cycles 1 to 2, 2 to 3, and 3 to 1. Both 1 and 1 to 3 are elements of S3 that maps 1 to G, but they are different group elements. Orbit uniqueness. It is a transitive action. It is a transitive group action. The orbit is unique in the sense that there is only one orbit, and that orbit is the entire set X. Group element uniqueness. The group element G that maps X to Y is not necessarily unique. There can be multiple group elements that achieve the same mapping. My brain is not braining. Yeah. Paranoia, 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 yeah. A group action of a group G on a set X is called transitive, and there exists a group element. So that G times X is equal to 1. The orbit of an element X under the action of G is the set of all elements in X that can be reached from X. Orbit is the set of all elements in X that can be reached from X. So X is set, and the orbit is all the elements you can reach from X with G in capital G. In a transitive group action, there is only one orbit, and that orbit is the entire set X. This means that for any X in a big X, the orbit of X is X itself. I still don't see the uniqueness. There is only one orbit, and that orbit is the entire set X. This means that for any X, the orbit of X is X itself. The group element that map is not necessarily unique. There can be multiple group elements that map X to Y. Yes, so I see in this example why, but I don't see why the orbit is unique. I guess maybe I'll understand later. Let G be in G. We have G in the kernel, as in PG equal ID. G x is bin G is equal E. Yeah. All group acts on itself by conjugation. It is an action, yes. If G is equal to 1, then it's just G. X, I mean. And then if you have a GH, like G x G minus 1, then we apply H. It's G x H G minus 1 because when you do the inverse, the positions get switched. Blah. We have orb of x is g and g next. G e g minus 1 is just equal to g to e. Yeah? If g is different from e, the action is not transitive. G is different from is an action. Conjugation, blah, blah, blah. So gh, yeah. Now we have the orbit of x. So yeah, we have g e g minus 1. And the only way for it to be equal to e is for g to be equal to e. I think. Let x in g, we have orb x is equal to gx, blah, 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 blah. Is the conjugation class of x, yeah, conj x. Consider the homomorphism P associated to this action. Break? Comment ça, break? What do you mean break already? I did nothing. Oh my god. Break, what? I guess since it's the force Pomodoro, we'll do at least a 10-minute break. Exercise, I don't know. Let's say 4. Did that count as exercise? I don't know. Am I progressing? I don't feel like I am. Let's say 10 minutes, yeah. La, 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 la. I'm sorry, I'm so mathematically challenged. This should be my catchphrase. Should charge my tablet. Ora, che sarà, che sarà, che sarà? Yawasetes, ora, che sarà, che sarà, che sarà? La 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 la. Come ah ah, e ci ne sa. Sarà se kaina da ci ne sa. Da, 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 da. Wanakai Maze. Da, da, da. Ah, 10 minutes already. Like cinema. Feels like I didn't rest at all. Usakunaida, Mojibano, Miteta, Kito, Kito, Kagami Sugi no niyoi, Shinaketa ka, Kawatte nakute yokatta, Pink no ikitsu no. So, bunny. スーパーメガこんなにも遅し、あなた気になってまよわ。あの右隣。Do I deserve some little snack? I guess. I mean, it's not good for the sleep to eat, but I'm 3 hours away from my sleep, and I'm kind of a uni student. I need my little my little remontant. Loco Bioli. Ah, I didn't do my bed today. Stupid. Completely forgot. Madame, tu l'as dit, non? Okay, I'll read 100 Girlfriend, 2 chapters are, and I'll go back to study. The new girl is so cute. Hein. Hippie girl. Hein. She's standing up, oh no. Oh no. She's literally Zenitsu. And the mouse are going on a date. Kawaii. Kawaii. Bonk. She looks like he's having fun, and so am I. So I guess it's fine. El Mao. She never rests, so cute. She falls asleep. Damn, those are some drippy shoes. She kiss. Let's go. She's so cute. Oh my god. Sekai no subete wa Masuguyo. Sekai no subete no koku no naka. How tasty. Nice some cheese. One more chapter. I really took like a 30 minutes break. Ah, voilà. If I have to, I guess. Ah, ma tablette, non! Hyundai je bout tablette. Son actual superpower cake. Kawaii. Nom 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 cheese. Kawaii. Le Baden en via canot. J'ai roll PTSD. Joshua Nakamura. De smooth. Cinéma. Absolute cinéma. Ouf de crash underground. Kawaii, kawaii. Ah là là là. I'm done. Ah là là là. I am satisfied from the cheese. I downed one fourth of my cheese, bro. Nah. Oh là là là. Thought that I'm still hungry. Fuck my life. Let's. Oh my god. Not allowed to be this hungry when I'm poor. Not allowed to eat so much when I'm poor. No. I should switch subject, I think. I think I'm gonna do differential equal calculus thingy. Wait, what class do I have to? I think I have only one class today tomorrow. So maybe I will be able to study all day again. I say again when I start at 2 o'clock. I hate myself. Know that I wake up at 5 a.m. I wake up at 5 a.m. and I only manage to study at 2 o'clock. So, kill me. I mean, it's kind of like the morning. I wake up and like around 7, 8, I'm ready. But then I kind of waste my time. And then I eat. So since I eat, I say I'm not gonna stream. So then I finish eating at like 10:30, 11, and then at 10:30, 11, I'm gonna eat my real food. So I'm gonna eat again, and then by the time I'm done, I'm done. Oh my, never mind. I have a lot of class tomorrow. You have class all afternoon. Wow. Kill me, kill me, kill me. My school depresses me. Life depresses me. That's the real word. The real term they use. Oh, putain de merde. Okay, let's continue. Let's continue, let's switch. Topology or I'd say topology. I'm more lost in topology than the rest, I think. Good exercises here. A video of cat being dumb is just あのねちょっと一回待ってちょうだいカリンカカリンカ犬のはじめこんな感情どうしようかあららららら私とランデブー、ランデブー、ランデブー。ねえねえねえ、もっといっぱい待ってちょうだい。カリンガカリンガ犬の味めこんな感情どうしようか。教えてくれないか。あやや。Okay, brothers, let's fucking na. C'est topologie. Topo, 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 topo. Logie. Topo, 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 topo. Topology. Did I finish the first page of it? No, I did not. Ah, yes, the norm. The big norm. Now, was I able to do the 5? This 5 or this one, and this one. Ah, yes, the OX. Ah yes, open means the limit is in is open, so the limit is in. So the limit. Ah yes, because you can find the ball where it is in the side. Oh my god, I can't. Okay, I know which exercise I'm gonna do. Cool. Script. Countdown.lua. Lisetto. 0. Oui. Go. Change color. Choo 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 choo. Choo 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 choo. It means X, it means A is closed. Man. No. Il est ouvert. Brain in French. I'm Frenching. Means that X is in A. Hmm. So yes. Close, close, close. Limit. Lim means the ball x xn is inferior to the ball x 1 over n, something like that. This is not. Okay, how do I write this here? I missed the first part of the exercise. Sorry.コランのスポンサーの提供でお送りします。すむ。Un ouvert démontrer que la réunion est un ouvert. Ah, yes. OX. Open. Union OX. Open. On I. I mean, X in I. Why X in I? It's open, then there exists X in OX such that the ball X are included in OX. It is included the union OX. So, wait. So also, for all X, there exists a ball X R in union open. So, union OX open for all X in I. Think it's that. Let me check. It's open, so this R, such the ball YR is included in X. I mean, yeah, I took X, but I should have taken Y in order to not mix the X. So X is the ball is included in the union, so blah blah blah. So it is open. Intersection. Intersection. Ah, yes, I remember the how to do it. So, let Y be in OXE. I mean OX1. No, OXE. OXE with E equal to 1 n. No, 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 no. And so there exists RE such that greater than 0 such that the ball YRE is included in OXE, included. No, we don't know if it's it. So we take R equal to the mean between all the R1, Rn, such that so the ball Y R is included in the intersection of OX. To vary for the finite intersection, and the intersection is not open in general. Ah, yes, an example. Oh no. Oh no. Why? I'm not able to think of an example. An example of why the intersection is not open in general. Ah, yes, I had to look at it, I forgot. Minus 1 over n. And we end up with 0, and it's closed. Part 2. Two. Fuga. Fuga, fuga. Ah, la, la, da, da, da. I'm stressed. Sudden rush of stress. A sudden rush of stress. Wait. Comment ça, il y a autant d'argent? Ah là 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 là. Oh my god. Stressed. Okay, let's just take the break now. I'm stressed. I lost my focus. Just to focus for 4 minutes. Stress, stress, stress. Stress, 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 stress. La, 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 la. I can do it. 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 So convergence toward X. So we can find. I suppose X is outside, right? Ah, yes, we suppose X belongs to X minus 1. Open. So there exists R greater than 0, such that the ball X however Xn tends toward X. EA, the distance between Xn and X is inferior to epsilon, epsilon greater than 0. And how do I conclude? I forgot the there exists n. There exists n in n such that n greater equal to n. We got blah 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 blah. Equal to epsilon. Okay, so this means xn belongs to xa. Contradiction, okay. So x belongs to, okay. Yareba dekiru, yareba dekiru, 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 dekiru. So we got xn in A, x in A. Need to show that xn is open. there exists r greater than 0 such that wait, take an I Greek or something? I Greek, yeah. This and I Greek in X thingy. You have the ball I Greek R in the intersection, right? Let X be inside the ball I Greek R such that X and N tends toward X on N. So how do I show Y R is in intersection R, yes, different from 0. Yeah, yeah. So for all N, blah, 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 so so for all N, there exists Xn in A such that the distance between Xn and Y is inferior to 1 over N. What? But they don't include X in there. So there exists N in N such that the distance between Xn and X is inferior to R. My 1 over the 1 over N is my R. So Xn belongs to Xn. Na, 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 na. What the hell is written there? So for all n, there exists xn in A such that the distance between xn and I Greek is inferior to 1 over n. So it is similar to my xn, distance between xn and x inferior to 1 over n, with x in the ball. So x the series xn is included in A. Why is it a so? It's not a so. We already set it. So the limit xn is equal x does not belongs to A. I don't understand the correction, but I understand what I did, no? Is it false? We got x in the ball, so that the ball is in the intersection, because it is closed. So we can reach it. With x, the limit x in A. So it creates a ball. We say the limit is in the ball. Then we create a limit with x in A. Since it tends toward x, it reaches x. However, x is in the ball that is in both of them. So xn belongs to x without A. Contradiction because xn is in A. Wait, so it does not work, right? But I don't understand the correction. Why is X not in A from what they wrote? X is mentioned nowhere before. I don't know. Exercise next door. The norm P, blah blah, power P, square root P, yeah, define the norm. Yeah. 1 and from R2 into R, a norm. Shows there exists C1, C2 greater than 0 such that, yeah, the norms are equivalent. Da, 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 da. Why is there the Pillarman team in this? What is this mismatched team? Uh... Mm. Ah, là, 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 là. Ah, la 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 la. I will kill Ginny Tadori myself. I will kill le salut. X1 is equal to norm X is equal to C2 X2. Ah non, c'est 1. N is a random thingy. Damn. Do note it was written by my classmate, who's way smarter than me. He's one of the best students in the class. The most studious and smartest. So he introduced the Lipschicity. The Lipschicity. I don't even know if the teacher asked this. He did more than the question asked. He proved the generality of the statement. Such a Chad. Makes me wanna KMSU. Ah d'accord, XP, ok. X1, XP, ok, I understand. Shows there existing. So we are supposed to remember that we had to use the Lipschitz property. Lipschitz is some continuity properties, but what does it mean again? I mean, you wrote it there, but really wanna. If I don't know it, I'm not gonna invent it. So. So what is Lipschicity? It is Lipsi thingy if for all x I y in E, we have that f of x at the norm fx. So the norm of the distance between the images is inferior or equal to the antecedent, which makes sense because if that wasn't the case, it would mean there will be some gap between both of them. So imagine we take x and y right next to each other, since it's for all. We would have f of x and f of y greater than the distance between their antecedent. So it will be continuous. However, it works if it is inferior or equal to, because if it's inferior to, it just means that the and since it is for all, we can just take x and y right next to each other again, and their image will be like maybe half a step, half smaller, so it works. Ah yes, because we can just play cat. We have x and y get closer and closer to each other, such that their distance tends towards 0, and you will have that the images end up also smaller and smaller and smaller at a greater space than x and y. So it proves that they are stuck together. So it's continuous. It's for all. The most important part of this property is the for all. Yeah, I see. And we cannot play cat and mouse if we have it greater than the antecedent. So with this, so now to show that nx and y is inferior or equal to xy. Alors n x y. It's a n, it's not a w. Ah, too big. It's already a norm, so no need to do this. Ah, it's minus. Yeah. Because the norm already implies the distance between both of them. That's why there's no need to do anything fancy here. Yeah, because the norm already is the distance between two of them. So nxy works, and it's not times, it's just between two. Is it two of them? That's norm. Is it a dot or is it a times? I'm not sure. So we show that the norm verifies the property of it's a minus, okay, I'm done. Is it with the triangularity of norms that n of x plus y is inferior or equal to n of x plus y? And if we play around with the signs and the minus and just, I guess we get up this. We get around with this. And so what does classmate do? So the norm is continuous on R, yeah. And then it's a K equal X R2, X2 equal 1. Le théorème des valeurs extrêmes. Man. Let K equal X in R2, X2 equal 1. 2, 2, 2. So the X2 is the one we want to see. So it is the set of all thingies so that the norm of X is equal to 1. So we take X in R2 and Y equal to X over the norm of X over 2, which is equal to 1. I think. Including belongs to K. Okay, I was wondering where the K was was going, was being used. So theorem of streams value. What is this theorem? I don't think we talked about it here, right? Neighborhood bounded set, definition, prop, subspace, definition, property. Wait, when I see theorem, do I write the name? I guess I don't write the name if there's no name given by the teachers. I don't see a single theorem. Nani? Here, theorem, limit unicity. I see a lot of definition, but no theorem. Now I'm scared about my note taking. Break. Yeah. My dad is calling.
Oui.